Alright, so in the last video we did long division and partial fractions. And so now we're going to do some of that we're going to do the partial fractions but with some u sub. So let's look at this and see what we might want to do. So we have this, and we want probably in terms of some ln's here, right? Because we have a one number over another number. And so we probably want the du to be a cosine x. And so, because it's on the top. And so we can let u be equal to sine x because it is on the bottom. And so that the du will be cosine x. So we're going to just write over here u is going to be equal to sine x, and du is going to be cosine x dx. Alright, so now we can rewrite this in terms of u. So we have u squared. So we have u, or we have du. Let's write that on top. And sine x is u. So we're going to say u times, or u plus u squared, because that is what sine squared means. And so now we can factor the bottom, because we see that we can, that is not the eraser. So now we see that we can just kind of say du over here. And so this, we still can't quite integrate. So we're going to do some partial fraction mess. And so we're going to quickly factor this as x u times 1 plus u. You can see that by just pulling out this u term. And so now we're going to have some partial fractions. So if you remember from the last video, we're going to let 1 over u times 1 plus u be equal to some constant a over the first factor u plus some number b over the other factor 1 plus u. Not c, 1 plus u. And so we're going to use this concept of partial fractions to solve for these values of a and b. And so we're going to multiply by the common factor over here. And so we have now 1 plus u times a, and now just bu. And so now we're going to substitute in values. So I'll switch back to green here. And so we're going to let u equal to 0 so that this term is 0. So we're going to have now 1 is equal to a times 1 plus u. And so if u is 0, so that's just going to be a. And so now we want the other term to be 0. So we're going to have negative 1. So u is going to be equal to negative 1. And so now negative 1 times b. So negative b is equal to 1. And so negative 1 is equal to b. And so now we can rewrite our integral with our terms of partial fractions. So I will do this in blue. And so our integral is going to be 1 over u minus 1 over u plus 1 du. And so now we can use our properties of logarithms, right? So, or our logarithm things minus ln of x plus 1. I think I put parentheses last episode, but it is x plus 1. Or it is absolute value, and plus c. And then we can now substitute back in for with our u. So ln of the absolute value of u, which is sine x. And I put x here. This is supposed to be u minus ln of sine x plus 1. Sine x plus 1, boom, plus c. And so, last episode I didn't really show this, but I'm going to quickly just rewrite this with some logarithm properties. So it could be the most simplified. And so whenever you subtract some logarithms, you could just say one number over the other number. So we could do sine x here over sine x plus 1 plus 1. Because whenever you subtract two logarithms, they could be written as one logarithm, just one over the other. And then we can't forget our constant of integration. So this is the very most simplified answer, but this answer also would be valid. But for multiple choice questions, you probably need to know kind of how to do that. Alright, so we have our integral here, and so what I'm thinking is how the best way to do this is, I see here there's a bunch of e to the x's, but it's already factored, right? These two factors multiplied by together. So we're gonna just kind of turn this e to the x into just some number. So we're gonna let u equal e to the x, and then we'll shove it back in at the end. So we're gonna have du equal still e to the x dx. And so this is very easy to replace. So we now have, let's see, u over when du and u are the same, my brain just died. Okay, so this is du, because we want to engulf this dx. So e to the x dx. And so then we're going to have over u minus 1 times u minus 4, u plus 4, and then take the antiderivative. And so we still cannot properly integrate this, so we want to find values of a and b to complete the partial fraction. And so we've done this enough times that I'm going to skip the writing it out and just in the cross multiplication and stuff. And so we're going to just say a times u. You know what? I won't do that. So we're going to have I'm going to write this, a over u minus 1, and then plus b over u plus 4 dx, or du actually. And so now we know that whatever is on the numerator, which is just going to be 1, so a times the other, so x, or u plus 4, u plus 4 plus b times u minus 1 is going to be equal to the numerator, which is just 1. Alright, so we want to solve for values that will make this equation true. So let's let u equal to negative 4. What is that going to do? That will make this term 0. So when u is negative 4, this term is 0, so we only have to worry about this part. So negative 4 minus 1 is negative 5, so negative 5b is equal to 1. B is then divide both sides by negative 5. It's negative 1 over 5. And so now we're going to do the same thing, but we're going to let u equal to 1 so that this term is 0. And so when u is 1, this is going to be 5a is equal to 1, and then divide both sides by 5, and so that a is equal to 1/5. And so now we can just basically copy paste this integral, but just put our constants in for a and b. So we're going to rewrite this integral of a, which is going to be 1/5. So 1/5 times, I'm going to write it in all on the numerator, just so we remember it's going to be a constant. So then u minus 1, and then plus b, which is negative 1/5, so negative 1 over 5, and then over u plus 4. U plus 4 du, and now we can use what we've been doing and say, put the constant, so that's 1/5, times the natural log of the denominator, u minus 1, I'll show that again, u minus 1 plus the constant, so which is actually negative 1/5, times, not times, well I guess it's times the natural log of u plus 4 plus c. And now we get to shove e to the x back in for u. So we have now 1/5 times ln of e to the x minus 1 minus 1/5 ln of e to the x plus 4. And these are absolute values. And plus c. And for this one too, I'm going to just do the logarithm property. But what we see here is we can pull this 1/5 out of them, and then we have this negative sign. And so we can have 1/5 times the natural log of this first term, e to the x minus 1 over e to the x plus 4 plus c. Just to give some practice for writing it in this form. That is u sub with partial fractions.